Thank you for watching Knowledge Academy. So now what we're going to do, you see a bunch of approximation. So what I want to do, I'm going to just connect in a dot and just move on a little bit faster here. If I have a random shape, right, I want to make a little segments. You guys still seeing my black screen, what I'm drawing right now, something?
Yeah.
Yep.
And I call these little lines, I call them lines. But it's not enough. I want to know where these lines are going, the direction. I want the direction. So I start calling them. You know what? Lines are not enough. I want to tell you this, these arrows. Okay. And these arrows, I start calling them vector. That's why this calculus 3 or multivariable calculus, vector is a very essential component, right? We're going to be talking about a lot about vectors. So let's talk about what are the vectors and scalars. Talk about everything in the world is physical quantity. Physical quantity. I teach physics many different places, colleges, universities, and CAT student. I'm a physics guru. And in physics, in the physical world, there's a little bit different perception of vector than math. In physics, we are talking about more on concept. In math, we are talking about both on focus on the solution rather than the theory. In physical, quantity means something you can touch, feel, and quantify. Touch, feel, and quantify. It means I want to asking you buy 2 pounds of banana. Can you touch bananas or apples if you want to buy them? Can you feel them? You're going to touch them before you eat. The thing is, so I consider mass as a physical quantity. Yes. I says time. Can you touch time by hand? Can you touch time by hand? But can you quantify time? Quantify. Hey, 1 hour, 2 hours. Yes, I could do that. So time is also physical quantity. Remember the definition of physical quantity means physically exist. It doesn't mean like they are physically available for you to touch and feel them. If you are not physically touch and feel them, you still quantify them. They consider physical. Love or hate. Love or hate. Can you touch them? No. Can you feel them? No. Can you quantify them? Probably not. If you quantify love and hate, then we have a problem. You say, hey, how much you love me? 84.5 love. It's going to be a problem. So love is not a physical quantity. Force. Can you feel force? Yes. Somebody try to push you, you can feel it. The force is a physical. Okay. So we have two kind of physical quantities. Some only need value. Some only need value. Or I say magnitude. Right? The better word is magnitude, but I use the word value. Here, let's do this. Force is also a value and magnitude. Magnitude means how much and where direction. Where is direction? So what I call these things which is only need value. I call them scalar, and vector. So let me just throw a question to you. What do you guys think? What do you guys think? The question is, you have to answer in the chat. Do you think every scalar is a vector? And the second question which you have to answer is, does every vector have a scalar part? The question is, every vector have a scalar part? If you're talking about force have a magnitude and direction. So it means every vector, yes and no. Kevin says yes and no. That's a great way to say that. Every scalar cannot be a vector, but every vector should have a scalar part. Okay. Anyway, so what you're going to do, I'm going to focus on vector. And force is my point. So I'm going to focus today more on vector. Does anybody who have a little bit trouble to understand vectors? So what I'm going to do now, vector is a few things. I'm not going to be I need a way I can do the vectors and talk about vectors. So the best way I can find out, I start making arrows. I start making arrows, 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 arrows. Okay. So two things going on with the vector. Number one is this guy, the size, and angle. Size and angle, right? It means if I say vector this called A, vector this called B. Which vector is big, A or B? Which one is big? Which vector is big, A or B? It's simple, right? Straightforward. I try to make these things super easy to digest. Now put the answer. B is definitely a bigger vector. Which vector is more steeper, right? It means which vector have a less angle with x-axis. Which vector have a less angle with x-axis? Think about it. Which vector have a less angle with x-axis? I draw it very close so you pay attention. B, right? B, you can say here this angle, if I this angle maybe 10 degree or something, maybe this angle is 15 degree or something. So you know this guy is a smaller, biggest vector and the smallest angle. So you learn two things. Size matter here. You cannot say size doesn't matter. Size matter here. Yeah. So now if size is matter, especially I'm doing some math, and what I can do, I'm going to do just really quick skim on that topic. If I give the vector called A, vector A, and I want to change the vector A direction, vector J direction on the other side, what I'm going to do? What I'm going to do if I want to change the vector direction on the other side, I can say, you know what, take A and multiply by minus sign. So you're going to get a new vector called B. So if B, I'm going to say is B equal to minus A, B equals to minus A, you're saying?
Yes.
Okay. Simple. If I want to make a vector C and C equals to half A, what I'm going to do, I'm going to take this A and then break into two pieces. I say, you know what, C equals to pretty much like this. Right. And same thing, if I gave you two vector, and let's suppose I give you two vector, that's a little bit different thing than what you easily figure it out if you never learn about vectors. I give you vector A and vector. Remember, vector needs some. First thing first, A have some vector, B has some vector. Let me put some size over here. Vector A is maybe 4 meter. Vector B is 5 meter. Okay, which vector is bigger? Let's pick someone who never answered me anything. How about J? J, are you there?
Yep.
Hey, J. J, which vector is bigger, A or B?
B.
B is bigger. I'm talking about below the line, guys. Just so you know, just below this line, so we talk about that. So J, I want this. I'm just writing J. Follow up with C equal to A plus B. Can I do that, J? Yes or no?
Yes.
Yes. What would be the ideal answer? Let's suppose J1, let's put it this way, J. If both A and B are scalar, what would be the answer? If both A and B are scalar, what would be the answer? 4 plus 5 equals to 9. But can I do that? No. Why I cannot do that, J? Because both are what?
They're both vectors.
Both vector. I'm sorry, I couldn't do it. That's not easy. So what I'm gonna do, I'm gonna make another rule called head to tail. Probably you guys learning head to tail. And head to tail rule is a rule we use for addition of vector. Addition or subtraction. Yeah, addition and subtraction of vector. So what is the head to tail rule, guys? I'm gonna do one thing. I'm gonna draw the vector A first. And then I'm gonna take on the head. So this is the head of the vector A. I'm gonna draw the tail of vector B. This is tail, and this is head. Where the arrow is, that's the head. And I'm gonna be drawing this vector B over there. And what J was just told me, J what I'm gonna draw with the resultant vector, C. C will be starting from where to where? Anybody helping me? If J doesn't know.
It's the tail of A to the head of B.
To the head, the tail of A, which is here, and head of this side. I'm gonna draw this. So yellow color vector is equal to A plus. Now, what I have to do, I have to take the ruler. I have to take the ruler. Literally, I have to take the ruler and go and then measure from A. And what is that? I don't know. Can anybody tell me by looking this graph without making the actual measurement, how big is a C? It's not easy, right? The easy way is just go and measure it. So I need to do measurement and find the C. Okay. But the thing is, if I'm asking you, think about it all. The vector C when I draw, did I draw the arrow on vector C? C is a vector. You cannot say that I add banana versus plus banana and my answer will be apple. If you're adding two bananas, the answer will be banana. So you're adding two vectors, answer cannot be scalar. It has to have a vector. Now, so if I give you 4.8, or my answer is complete, or I need, and what is the direction? That's the question. I have to measure to this angle. Remember, I have to measure always with the positive x-axis for standard. So this is my positive x-axis. So I'm going to measure this. What do you guys think? Is that theta I needed in order to give the direction? Right?
Yes.
Right. So just so you know, if you have a protractor, there's another thing called protractor where you just measure the angle. You can use that one, or you call D. Some stationary language you call D. So there is a D-shaped instrument we use it to measure the angle, and you use the compass to make that angle. There's a bunch of ways you can measure the angle. And if you gave me the angle, I'm happy about it. Okay. So we learned two things: direction matter, size matter. So let's move on to some things. So now what I'm going to do moving forward, I'm going to move to another slide. And I'm going to talk about some awesome graphs. There you go. Now things are much better. So I'm going to be drawing the vector. Let me just draw the vector, just like the real vector. It's the invisible vector. And yeah. All right, I just pretty much done with my vector drawing. I call this black vector called A and the blue vector called B. Since direction matter, size matter, and what I want to include the size in a graph paper. I says one square is 1, 2, 3, 4, dot, dot, dot. This is 1, 2, 3, 4, dot, dot, dot. This is -1, -2. So let me ask you one thing. Can you guys put on a chat I'm going to call this is called P, Q. I get two coordinates, I'm not going to talk about what are the coordinates because uh, R as coordinates you guys learned long time ago, algebra. So P have two coordinates, yeah, X value and Y value. I'm going to put the P value is 3, comma 2. Can you guys put the coordinates of Q in a chat? Put the coordinate of Q in a chat. It's hard to measure. 5, 6, 7, 8, 9, 11, 12, 13, 14, 24, 5, 6, 7, 8, -4, -5, -6, -7, -8. Okay, pretty much most of you all already put the coordinates, and the coordinates is 11 dot or 11 comma 8. This is 11 comma 8. Can you guys also put in the coordinates of R and S? R and S. S is -3 and 7, and sorry, R, and S is -2 and 7. Okay, -2 and 7. We got R and S, everything. Now I'm wondering about this. I'm wondering about two things. Number one is size and direction. Let's talk about the size. We will talk about the direction later. Let's talk about the size. In order to find the size, I really want the size of this vector. Let's suppose A, I want the size. How big? How big is A? So the formula is, I'm going to say PQ equal to x2 minus x1. The two, so this is x1, this is y1, this is x2, this is y2. So I'm going to say x2 minus x1 plus y2 minus y. I'm going to substitute the value real quick. And that's the formula I'm using for PQ. And I'm going to put this sign. This sign means I only care about value, not the sign. Like I don't care about the minus sign or plus sign. I only care about positive part of this vector. So x2 is 11 minus 3 squared plus y2 is 8 minus 2. 11 minus 3 will be 8 squared plus 6. It's going to be 64 plus 36. And if you add them, will be how much? Square root of 100. If you take the square root of 100, you're going to see it's going to be 10. So really, P and Q vector is 10 meter, 10 kilometers. I don't know what is that, 10 meter, 10 kilometers, 10 millimeters. It is 10, A equals to 10 meter. That's or millimeter, kilometers. It depends on what unit we are using. At this point, I'm not going to be stuck any unit. I just leave it there. And that's the way it's going to be done in the math. Usually we don't talk about unit, but in physics, we do talk about unit all the time. Okay. Can you guys give me R and S? Calculate R and S, give me the answer in the chat. Make sure you at least you're writing those formulas. I'm asking R and S, which is on the left side. minus 2, then minus 2, minus 10, then 3. I'm going to be writing like this. The worst thing you do in math is try to solve everything in your head, which is not a right thing, guys. And it's going to be minus, it's going to be 7. Oh, sorry, this is not going to be, it's going to be 2. Okay, so 7 minus 2. So it's going to be minus 2 and plus 3 is going to be 1 with minus sign, right? So 1 plus sign, and then it's going to be squared. And it's going to
Shouldn't
be
x1 be -8? I don't know how it's -3.
Sky. Hold on. I think I messed up with this number. Let's do this one time. So this one is going to be minus 7, right? Minus 7 and 2. And the other one is going to be minus 2 and then 7, right? So let's do minus 2 minus 7 and then 7 minus 2. Or if you just want to do R and S, is going to be 7 minus 2, because we are doing minus 2 minus 7. Okay, now looks good. And that's going to be plus 5 squared plus 5 squared. So 50 square root. You're not going to be leaving this 50 square root. You can say it's 5 times 2, so maybe you can say it's 5, 2. You can leave it there. Or if you want to be solving further, you can solve it further. It's going to give you the answer. But R and S, if there is any minus sign involved, you have to ignore it, because I'm using these bars. These bars means I can ignore the minus sign. Okay. Now, I got this part is done. When I want to write the vector, I'm going to be writing the vectors. Writing vectors. I'm going to keep it and doing it here, since we are already calculating this. So over here. Vectors. Right? Vector. So what I'm going to do, I'm going to be just drawing something. So what I did, I just take a laser and I says, I'm going to take P and Q. So I'm going to take P and Q. And I want to measure how much is on big on X and how much or how big is on Y. How big is on X and how big is on Y. So X means I want to know how big is from here to this guy. And on Y, I want to know how much is here. Okay. So I'm going to be just writing here, guys. Let's take the red color marker and I say I'm talking about right now. Vector A equals 2. Maybe I can say vector A equals 2. V1 and V. V1 and V2 are two components of a vector A. Okay. And I'm going to be using these kind of parentheses. A have two components, V1 and V2. And I'm going to call here is maybe just for now, for simplicity, maybe you can call them X and Y. A vector have X component and Y. So I'm going to measure the X from here to there. This is my X component. And that is my Y. x component and y component. And what I'm going to be doing, in order to calculate the x component of A, I can take, for x component, I'm going to take x, which is 11 minus 3. So I'm going to say 11 minus 3. And if in order to calculate y, it's going to be 8 minus 2. So I'm going to write here. Write this way. Says 11 minus 3 and 8 minus 2. What would be the answer if I do this? 8, 6. Right? So really, what does that mean? This 8 and 6 means if I make a vector 8 here and make the vector 6 here, if I connect these two vectors, I'm going to get a vector, which is my vector. And what is the length of vector A? What is the length of vector A? You already calculated.
10.
10. See, this is 8, this is 6, this is 10. Now, I want to write vector in components, so you're writing 8 and 6. So another thing is that I can write 8 and 6, or I can write like this, 8 equals to 8i plus 6j. So bottom line is that you can also say I is the x component and j is the y. Yeah, if you guys want to leave, you can leave it right now. We almost try to wrap up this one. Can you guys, before we wrap up this one, I want to write the same expression for vector B. Can you guys tell me how can I write vector B? I'm not going to make these parentheses, guys. When I write here, when I write vector in a component, I do not use these parentheses. I'm going to be using the other parentheses, which is only used for vector, like this. Can you guys tell me what should two component of vector be? What two component of vector B? Some people say it's 5, 5, 5. Yep, 5, 5. What other ways I can write this 5, 5 for vector B? If I want to write in a component form. Yeah, 5i plus 5j. 5i plus 5j. Okay, so what I'm going to do, I'm going to just razor use this diagram. One more thing. While I'm going to do the attendance, can you guys try this? U, V, I'm giving you coordinate. See the value. I'm going to use parentheses. U is a coordinate. V is a coordinate. U, V, yeah, U, V. The size of the U. Tell me what is this, and also tell me U, V in a vector form, and also tell me U and V. What other form I can write in I and J form? So tell me U and V in a U and V in I and J. Let me open the attendance and I can jump into attendance while you guys working on this. And we can just wrap up this call. 2 and 2 or minus 2i comma 2j. So if I want to write in a vector, see, one thing is that when I says without these parentheses, I write 2i with minus sign and 2j. Pay attention what I'm doing is very important thing. When I do not use these parentheses, I use 2i with this plus sign. 2j. You notice a little thing, when you do inside parentheses, you're writing a comma. When you're writing without parentheses, you're writing plus sign. It means it's a combined vector. Thank you for watching Knowledge Academy. Please subscribe my channel.